Some good news and bad news, I guess, going into section 8 of chapter 6 is graphing radical functions. So I guess good news is that this is very different from finding our inverses, if you didn't really like that. Bad news, I guess if you are sick and tired of transformations, you get to see them again, yay! So graphing radical functions, here we go. We have worked a lot in chapter 6 with square root and cube roots, and even more roots than that, but we haven't really talked about what the functions themselves look like. So our parent functions are y equals the square root of x, and also y equals the cube root of x. These are the two parent functions that we're going to be working with, and all of our transformations are based off of those two functions. Okay. So right below here, I'm going to draw in what those parent functions would look like. I'll rewrite this up here so I can scoot this up a little bit. Y equals the square root of x, y equals the cube root of x. So for y equals the square root of x, let's think about some values for x that we could plug in. If x is 0, square root of 0 is 0. If x is 1, square root of 1 is 1. And notice too that it's just 1, 1. 1 negative 1 isn't an option because this square root already being there implies that it's just the positive. And then the next number that we could square root nicely is 4. Square root of 4 is 2. Next number after that we can square root nicely is 9. 9, 3. And my function, if I connect the dots, looks like this. So you might be thinking, does it really stop here? Does it keep going? Do I want an arrow on this end? It stops here. No arrow on this end because I can't have a negative x value. Negative x value would give me something imaginary. So stops here, does not keep going. Here on we go. Cube root of x. Remember, we're talking about one number can we take times itself again to give us x, I guess. So 0, the cube root of 0 is 0 because 0 times 0 times 0. 1 we can cube root. And then 8 is our next number we can cube root nicely because 2 times 2 times 2. The difference between our cube root and our square root, the biggest difference, I guess, is that we can have negative x values. Negative 1, for example, the cube root of negative 1 is negative 1. Because if I take negative 1 times negative 1 times negative 1 again, that gives me my negative 1. Negative 8, we can also cube root and get negative 2. So my cube root function looks a little bit more like an S. These are my parent functions. Make sure you have these down somewhere. Okay. One other thing I want to say before we start actually graphing is that all of our even roots, whether it's a square root, fourth root, sixth root, all of those even roots are going to have this shape. Now, we might have different x and y values, but all of our even roots will have an endpoint and go on one direction. All of our odd roots we'll have that squiggle, kind of the S shape. And again, we'll have different x and y values depending on what the root is, but they're all kind of the same shape. And this is kind of the same idea that like x squared, x to the fourth, x to the sixth, they have the same shape. Both of them had both ends going up, where our odd degree polynomial functions, one end goes up, one end goes down. And you might hopefully see some of the similarities there. Even with my parent function, square root of x, looks like half of a parabola sideways. And cube root of x, if I flip this graph on its side, that looks like a third degree polynomial function. So again, hopefully you see some of those similarities there. All right, my first example, I'm going to graph. I'll write this here. Example 1a. Let's graph the function y equals 2 times the square root of x plus 1 minus 2. And biggest thing here is remembering what your transformations do. This 2 is my vertical stretch. This plus 1 on the inside. Remember, everything inside is horizontal and it does the opposite of what we think. So this is going to go left 1. This minus 2 goes down 2. Now let's think through our parent function as we figure out what the new one's going to look like. So I'm going to draw my parent function in here first. My parent function is drawn in the green. Now with the red, I'll do these transformations. Remember that transformations follow the order of operations. We would start on the inside and work our way out. So each point, we're going to go left 1. Then that vertical stretch, I take my y value times 2. 0 is my y value times 2 is still at 0. And then minus 2, I go down 2. This point, I go left 1. Vertical stretch, take my y value times 2, down 2. This point, left 1, take my y value times 2, go down 2. And my last point here, go left 1, my y value is 3, but take that times 2, brings me up to 6, down 2. After all of these transformations, my function looks like this. So even though we moved left, we moved down, or that vertical stretch, hopefully you can see that shape, it's really stretched out.